Okay, first step again, I'm going to mark in the vertical displacement. If you're not sure where it is, just count bottom to top as 6 units. So half of that is 3. So I can go 3 from the top and get the vertical displacement, or 3 from the bottom. That 3 is also the amplitude. So the vertical displacement on this is 1 up, and the amplitude is 3. I want to find the period now, and usually I'll go maximum to maximum, but the maximums are not nice, so it's not easy to find the period from the maximums. So I'm going to look at the vertical displacement, and I can see that the intersections between the function and the vertical displacement are very clear and easy to read. So really, I can find the distance between 2 points that are intersecting with the vertical displacement, but be careful, you have to skip an intersection because we want a full cycle. A full cycle is from any point to where the graph repeats, not where a point repeats. Now I can just count the period. It's 1, 2, 3, 4, 5 squares. So the period of this function is 5. So that means the b value is always 2 pi over the period. So the b value is 2 pi over 5. Now to find the phase shift, I have to make sure I know, is this a sine function or a cosine function? Well, because I can't see the maximums very well, I'm going to make this a sine function. So a sine function always starts in the middle, which is at the vertical displacement, but it's going up as you go to the right. So I'm just going to mark all the possible phase shifts with little arrows pointing up. And my phase shift is going to be the one that is closest to the y-axis. The closest to the y-axis is the one that's 2 to the left, so that's the phase shift. And now we have everything, so we can write the equation. Y equals 3 sine 2 pi over 5, x plus 2, because it's going to the left 2, and then plus 1, because it's going up 1. Brackets around that 2 pi over 5, x plus 2 is optional, but if you're going to graph it on your calculator to check, the black brackets are required.